In section 4.2, we're going to solve systems of equations. But as we saw at the end of section 4.1, solving by graphing has its shortcomings. It's kind of a pain sometimes. So what we're going to do is we're going to solve systems of equations by substitution. So solve by substitution. What's that going to entail? Well, problem number 14 is a nice example of substitution. You have two equations and two unknowns. That's why these are called 2 by 2 systems. It's the number of equations and the number of unknowns. Systems of equations get much, much bigger than 2 by 2. 100 by 100, 1,000 by 1,000, 10,000 by 10,000, and a lot bigger. But we're going to keep it kind of small, 2 by 2s. We're still looking for the same thing. We're still looking to see if and where two lines cross each other. But we're not going to look at the graph anymore. We're going to solve it by substitution. If you notice in this equation, I have y equals 3x. So what I'm going to do is I'm going to take this expression here and plug it into the other equation. What's that going to look like? Well, I have x plus what? 3x equals 4, and that looks good. Now, the nice thing that happened here is that all of a sudden, my equation just depends on one variable, right? What's x plus 3x? 4x. So if 4x equals 4, what does x equal? 1. Cool. Well, if x equals 1, what does y equal? If x equals 1, y equals 3. I don't know how to tell you this, but we're done. Cool. So faster than Donald Trump can create controversy, we got our solution. Cool. It was. Wait, here we go.
That was easy.
Yes. Cool. Now, let's do that again. Now, they are going to get a little bit more challenging, but the idea is the same. That you're going to get an expression for one of the variables and substitute it in the other equation. Let's try problem number 16, kind of another warm-up problem. 2x plus y equals negative 7, and y equals 3x plus 8. Well, again, the nice thing is that you've got one of the variables solved for. We've got y all by itself here. I can take this expression for y and plug it in over here. So let's do that and see what happens. So I get 2x plus 3x plus 8 equals negative 7. All right. If we combine the like terms, what would I get? 5x plus 8 equals negative 7. All right. Looking better. Then what? Yeah, thank you. Subtract 8 from both sides. 5x equals negative 15. X equals what? Negative 3. Now, if x is negative 3, how are we going to find y? Madison? Yeah. Plug in for x. So y equals 3 times negative 3 plus 8. Negative 9 plus 8 is what? Negative 1. So I'll give you a couple possibilities. On the exam, if you want to, just circle your answers like that. That's fine. In the book, if you looked up your answer in the book or on WebAssign, something like that, what you would see is negative 3 and negative 1. There you go. Negative 3 and negative 1. Nice. It's always going to be in alphabetical order, X then Y, or A then B, C then D, etc. Are you okay with problem 16? Let me ask you a follow-up question. Let's go over and graph this. If I graph these two equations, are they going to cross? And if so, where? Yeah, they should cross exactly where we just solved, at -3 and -1. So let's let me just grab this one and redo that one. So that'll be 2x plus y equals 7, -7, and y equals 3x plus 8 equals 3x plus 8. Now let's actually graph a couple things here. And perfect. Take a look where these two lines cross each other. Right there at -3 and -1. So it's nice. Even though we don't have to look at the underlying graph anymore, it's still nice to know and see that that happens, that the two lines cross each other, etc. All right, let's try problem number 22 next. Let's go back here, problem 22. (2x plus 3y equals 11, and x minus 2y equals 2. Okay, same thing here, except we have to do a little bit of work now to solve for x or solve for y. We're not giving it to us on a platter like we were in the last one. The last one, he had y by itself already solved for. We don't have that in problem 22, but we can get it. Is there a way to easily get x or y by itself from one of the equations? Yeah, if you look here, x is almost by itself, has a coefficient of 1. So if we add 2y to both sides, I get x equals 2y plus 2. Great. And now you can substitute that into the other equation. So let's take that and plug it in here for x. 2 times 2y plus 2 plus 3y equals 11. James, look okay? Okay. 4y plus 4 plus 3y equals 11. Robert, what should I do to solve here? All right, plugged in there, distributed. All right, good. So 7y plus 4 equals 11. Subtract the 4 as suggested. What does y equal? Y equals 1. Now, if y equals 1, let's kind of keep track of that. Y equals 1. Let's take that y equals 1. You can plug it back into your system of equations in any of 3 places to solve for x. You could substitute in here, A, here, equation B, or here, equation C. What place does it make the best sense to plug in the value for y to get x? I'd do it in C, because you've already got x by itself. The other equations, you'd have to do at least a modest amount of work. It doesn't make a huge difference, but make your life easier. 2 times 1 plus 2 is 4. Yay. So x equals 4. That's the other part of our solution. What if you're all done with this and you're like, you know, I'm not sure I really trust that answer. I didn't do so good on one of the tests. I want to make sure I do good on this test. How could you prove that you got that right? Yeah, plug it in. Now your point here, which is coordinates of 4 and 1, should satisfy both equations. 2 times 4 is 8, plus 3 times 1 is 11. Oh, okay, it works in the first one. 4 minus 2 times 1, 4 minus 2 is 2. It works. There's no reason you should get these wrong on an exam if you want to take the time to check it. Because you'll be able to find out real quickly if you got it right or not. Looking okay with problem 22? Okay. Let's try problem number 24. (4x plus y equals -5) and 2x minus 3y equals -13. Kind of like the last one, you're not given y equals something or x equals something. We have to solve for one of those variables. What variable does it look like it's easiest to get by itself? First equation, and what variable? Y. So, Dwayne, what am I going to do to get the y by itself here? All right. Yeah, perfect. Thank you. So I'm going to subtract 4x from both sides. That gives me y equals -4x minus 5. If you write -5 minus 4x, that's fine. It's still going to work out the same. Jaylin, now what? Good. So we're going to take this expression and substitute it into the other equation for y. Make sure you don't substitute back into the same equation accidentally. So that's going to be 2x minus 3 times -4x minus 5 equals -13. Madeline, now what? What do I get? Mm-hmm. Good. So if you distribute and then combine like terms, we end up with 14x plus 15 equals -13. If you're not comfortable subtracting -13 minus 15 in your head, do it on your calculator. I don't want you to get this wrong because you make an addition or subtraction error and end up with -2 as opposed to -28. Last but not least, I'll divide both sides by 14 and end up with x equals -2. Yay. So that's one part of my solution. X equals -2. Rochelle, what am I going to do to figure out what y is? Good. -4 times -2 minus 5 is 8 minus 5, which is 3. Thank you. So here, what you'd find in the back of the book or on WebAssign would be something like this. -2 and 3. Let's see. Preston, is this system of equations consistent or inconsistent? All right. Is that a guess or is that confident? Consistent. Why is it consistent? What does it mean to be consistent? There's at least one solution. And guess what? We found our solution. Now, these two lines are different. They're different graphs or different equations. So not only is it consistent, but it's independent. Shane, if I took the time to graph these, are they going to cross each other? If I graphed, say, this equation and this equation, are they going to cross each other? Think so? Good. McKenna, he thinks they're going to cross each other. Are they going to cross each other, and if so, where? I don't know. Some help? Yeah. So they are going to cross each other, and that's where they're going to cross each other. It's right at that point. Even though we're not graphing these things anymore, we're still trying to find where these lines cross each other. And that's that point. Let's try problem number 44. Now, leave yourself some space as you write this. It's c over 2 plus, and then leave yourself a good amount of space, or at least enough space. C over 2 plus d over 14 equals 1. And then the other equation is c over 5, and again, leave yourself a good amount of space after the minus d over 2 equals negative 33 over 10. Yeah. So not the prettiest looking equations. In fact, a lot of you probably would go, ugh, I don't like that. Yeah. So these are the ones you skip on the homework? Probably. Well, tell you what. How about if we make this a lot easier for ourselves? Is there anything I can do to make this a little bit more friendly? What could I get rid of the fractions, for instance? Multiply by what? What's the lowest common denominator between these two? 14. So that's what I'm going to do here. Is I'm going to multiply everything here by 14. So this by 14, this by 14, and this by 14. Now, a couple of these are fractions. So let me write that as 14 over 1. This one's not a fraction. I'm not going to get any cancellation, so I'm not going to bother to write it as 14 over 1. It's just 14. In fact, what's the right-hand side simplify to? 14. I was hoping you didn't need to pull out your calculators. That's good. All right, so on the left-hand side, let's see if we can't do some more simplification. Well, there's a 2 here. 2 goes into 2 once and into 14 how many times? 7 times. So I end up with 7c plus what? Yeah, 14 here cancels out altogether, so it's 7c plus d. Okay, that looks a lot better. Shane, would you agree? Does that look a lot better than what we started out with? Okay, all right. Thumbs up from Shane. Good. Let's move over to this one. What am I going to multiply by here to clear out all the fractions? 10. Yeah. This time we're going to multiply by 10. All right, so everything's going to get multiplied by 10. And see if you can't do that cancellation for yourself here. So this one by 10, this one by 10, and this one by 10. Now, since these are all fractions, I'll write them as 10 over 1. I'm writing as fractions because I want to encourage you to do that cancellation. Roy, what am I going to get when I do that cancellation, please? Good. 2c minus 5d actually the 10's cancel, right? 10's cancel, so you're just left with negative 33. All right. Are we comfortable with that? All right. Now the rest of it is stuff that we can solve by substitution. How would you solve this by substitution? LeBaron, what would you do? What variable would you substitute for? What looks easiest to work with? D. Yeah, from the first equation. Let's move the 7c to the other side. So you can subtract 7c, or a lot of times I'll just draw an arrow, move it to the right-hand side, because it's going to change signs when it changes sides. Okay. I've got an expression for d here. Let's put that in over here. 2c minus 5 times negative 7c plus 14 equals negative 33. And that's a 14 despite what it looks like. If I distribute the negative 5, I end up with 35 minus 70 equals negative 33. 35c. On the left-hand side, we're going to combine like terms. I get 37c minus 70 equals negative 33. If I add 70 to both sides, what do I end up with for c? C is 1. Yay. All right, so if c is 1, hey, great. Let's see here. No pun. Sorry. C is 1. If I plug that in for d, I get d equals negative 7 times 1 plus 14. Negative 7 plus 14 gives me 7. On an exam, it's enough just to circle both answers like that for me. I really appreciate it. If you want to go one better, if you're to write this as an ordered pair, it'd be 1, then 7. You do it in alphabetical order. So that'd be fine as well. But this or this, please, for an answer. Make sure you give me both. If you leave one off, if you tell me what C is and not D or vice versa, you're going to lose a point. Okay, we're almost done with this section. You guys are doing real good. There's just a couple little bitty things that I want to take care of here to wrap things up. Some other things that can go on when you're solving a system of equations by substitution or other methods. But up till now, we've used substitution when we had a system of equations like this that had a solution. What happens if you apply the method of substitution to a system of equations like this? Or system of equations where the lines were the same. What happens then? Well, let's find out. In fact, I don't know, would it be helpful to just apply this system? Yeah, you know what, tell you what, we'll just solve a couple of different problems. Let's start with problem number 38. (8y equals 15 minus 4x). Still 4.2. 8y equals 15 minus 4x, and x plus 2y equals 4. Now, I kind of want to finish up this section in a little bit of a hurry, so I'm going to do this. I'm going to move the 2y to the right-hand side and get x equals negative 2y plus 4. If it changes sides, it changes signs. Okay. Let's take this expression here and substitute it in for x over here. So what do I get here? 8y equals 15 minus 4 times negative 2y plus 4. So 8y equals 15. I'm going to distribute the negative 4 here. It'll give me 8y minus 16. Are there like terms on the right-hand side? Yeah. So thank you. I get 8y equals 8y minus 1. And if you look at that, it might start looking kind of strange. Wait, how can 8y equal 8y minus 1? It gets worse. If I tried to get y on itself by itself on one side, by subtracting 8y, I end up with 0 equals negative 1, and now I know there's a problem. 0 does not equal negative 1. That's not true. So what's going on? There's no solution. What's happening with the lines? If I graph those two lines, what would happen with them? What would I see? They won't intersect. And the reason they won't intersect is because they're parallel. So if I were to graph them, 8y equals 15 minus 4x, and then x plus 2y equals 4. Now, let me zoom in a little bit. There you go. You see the two lines are parallel, so they don't cross. Yay. Now, if you're working with a system of equations, you run across something like this where the variables drop out, and you end up with something that's not true, then that means it's inconsistent. That's what's going on here. It's inconsistent. There's one last thing that can happen. It's problem number 38. 3a plus 6b equals negative 15. And you want to talk about something that's tailor-made for the substitution method, it's this one. Look, this is like the problems that we started out with. You've already got an expression for a. We're going to substitute that into the other equation here. 3 times negative 2a minus 5 plus 6b equals negative 15. It's 2b. Right here. Negative 2b. Oh, okay. Thank you. B. So negative 6b. Thank you. That'll make a big difference. Negative 6b plus 15 plus 6b equals negative 15. And let's see. Well, these cancel each other out, right? What am I left with? You know what? That should have been a negative 15. Man, I'm glad this section is almost over. That's a negative 15. These cancel each other out. I'm left with negative 15 equals negative 15. Well, duh. Negative 15 does equal negative 15. But what's that saying about my solution? It's the same line. What you should see about this is that it's true. If the variables drop out, one of two things have happened. Either the lines are the same or the lines are parallel. You're not going to get a consistent independent system from a system that the variables drop out. So it's the same line. It's consistent independent. Dependent. Thank you. Yeah. Boy, let me reiterate myself. I'm glad this section is over. Starting to make mistakes here myself. For homework, try 13 through 47. Odds.